Hello and a warm welcome to you. I hope I find you well. This is Mr. T. Thank you for tuning in. Your viewership is highly appreciated. This will serve as an introductory video to sequence and series. In this specific video, we're going to be covering two aspects which your teachers would have done a fantastic job in teaching you. So we're looking at an arithmetic sequence together with a geometric sequence. So we're just recapping on what would have been done, just to remind you, only touching the surfaces, not getting too deep. I encourage you to watch the videos that are going to come after this one, which will deal with specific examples, more practice videos. So stay tuned. So to start with, I'm going to give you the definition of an arithmetic sequence, the formal definition, through saying the linear pattern has to have a common difference. So by definition, an arithmetic pattern has to have a common difference between consecutive terms. I'm just going to highlight the important things there. Common difference between consecutive terms. Notice that your common difference is denoted by the letter D. Hence, you see that D over there. Now, how do we calculate that D? That D is calculated through saying D is equals to T2 minus T1, underpinning the importance of subtracting the difference between consecutive terms. Generally speaking, this is given by Tn minus Tn minus 1. Still, these are consecutive terms. The general formula, though, is given by a plus n minus 1d. Very important. The general formula of any arithmetic sequence is given by Tn is equals to a plus n minus 1d, where your a represents the first term, your d represents the common difference. You already know how to calculate the common difference. We say d is equals to T2 minus T1. Your a is your first term. Just to give a general overview, if you're given T1, T2, and T3, we know that T1 represents your first term a. But to get to your a plus d, you would have added to the first term d to give you a plus d. Then obviously to the third term, you would have added to the second term d as well to get a plus 2d. This is just to give you a general overview of what each expression should be when it comes to an arithmetic sequence. We move on straight to an example. You are given 3, 7, 11, and 15. Now, having been given that, just to play around with that sequence, to calculate the common difference, you are subtracting the consecutive terms. You are getting a 4 and a 4. That's your constant difference D. And your A becomes 3, obviously, because your first term. Therefore, your Tn there, in general, is a plus n minus 1d as previously highlighted. But to be more specific, for this specific sequence, we're going to get 3 plus n minus 1d, and your d is 4. Then obviously you can distribute to get 3 plus 4n minus 4. Simplifying, you get 4n minus 1 as your general formula. So that's how you get your general formula. We move on to a geometric sequence. I'm going to start off by defining what is a geometric sequence, which is also exponential in nature. A geometric sequence has to have a common or a constant ratio denoted by the letter R between consecutive terms. Same thing, almost the same thing, but notice that it's a common ratio, not common difference. So that's the only difference there. So how do you calculate your R? You calculate your R through saying T2 over T1, which is the same as Tn over Tn minus 1. Very important. Then we proceed to say the general formula is Tn is equal to AR to the power n minus 1. That's how you calculate the formula. So within that formula, you need to know that A represents the first term. Your R represents the common ratio. Very important as well. To generalize it as well, T1, T2, and T3. Your T1 is A. Your T2 is AR. Your T3 is AR to the power 2. So how did we get the AR? We're saying the first term A times the common ratio to give us the second term. The second term times R to give us the third term, AR squared. Very important as well. Now, let's consider the following. You're given 2, -6, 18, and -54. Let's play around with that sequence as well. We're going to say R in this context would be T2 over T1, which is the same as negative 6 over 2, and that will give you a common ratio of minus 3. Moving along, your Tn will be AR to the power n minus 1. Your Tn would be 2, your first term, times the common ratio negative 3 to the power n minus 1 to give you the general formula.